Welcome to the DIY Honda Garage channel. DTC P0703 indicates a malfunction with the brake pedal position switch, NC. This component plays a vital role in ensuring the vehicle's cruise control system and idle stop function properly. If the switch fails, it can cause various operational issues that may affect vehicle performance and safety. Importantly, the condition leading to this DTC can often occur when the accelerator pedal is pressed lightly, while the brake pedal is also pressed continuously for over 5 minutes. In a typical Honda Civic from 2016 to 2021, the brake pedal position switch is located near the top of the brake pedal lever, making it essential for registering braking actions effectively. Proper operation of this switch helps ensure that systems relying on brake status receive accurate signals, thus maintaining vehicle safety and functionality. The brake pedal position switch is a fundamental component that communicates the position of the brake pedal to various electronic systems in the Honda Civic. Its primary role is to ensure that when the brake pedal is engaged, systems like cruise control and engine idle management are appropriately disabled or modified to ensure safe driving conditions. This switch is installed at the top of the brake pedal assembly, making it accessible for maintenance checks and troubleshooting. The DTC P0703 is triggered when there is an issue with this switch, such as failure to send a signal to the engine control module, ECM. Troubleshooting this DTC is critical because a malfunctioning brake switch can lead to unintended acceleration or failure of safety features. The Honda Diagnostic System, HDS, is typically utilized to check the status of the switch and associated wiring to determine the nature of the failure. Some of the potential causes for the DTC P0703 include a faulty brake pedal position switch, which may fail due to wear and tear or electrical issues. If the switch is not installed correctly, it may not function as intended, leading to erroneous signals. Additionally, there can be issues with the wiring itself, such as an open circuit, which can prevent electrical signals from properly transmitting from the brake switch to the body control module, BCM, or powertrain control module, PCM. Environmental factors, such as moisture or corrosion, may also contribute to electrical failures. Each of these causes can disrupt the communication lines between the brake pedal position switch and the vehicle's computational systems, impacting safety and performance. Understanding these causes allows for a more targeted approach to troubleshooting the code. The symptoms associated with DTC P0703 can have significant implications for the driver. One of the most common symptoms is the failure of the cruise control system, which may not disengage or improperly engage, representing a serious safety risk. Drivers might also notice erratic engine idle behavior, which could lead to a rough driving experience or even stalling. Additionally, warning indicators may illuminate on the dashboard, signaling that there is an issue with the braking system or related components. These symptoms can vary in severity, but should prompt immediate inspection to avoid potential driving hazards. Recognizing these symptoms early can enhance vehicle safety and reliability, ensuring that no further complications arise from this DTC. Begin the troubleshooting process for DTC P0703 by turning the vehicle to the on mode without engaging the brake pedal. Utilize the Honda Diagnostic System, HDS, to check the brake pedal position switch signal parameters. It's crucial to verify that the parameters such as cruise brake SW, IDL stop SW display a close condition while the brake pedal is not pressed. If the current conditions align with the expected threshold, proceed to step 7 of the troubleshooting process. Conversely, if the parameters do not match the specified values, this indicates a potential issue with the brake pedal position switch or its wiring, necessitating further investigation to identify the fault. Accurate readings from the HDS are essential in isolating the problem and ensuring efficient repairs. For the second troubleshooting step, begin by turning the vehicle off and ensuring it is in the lock mode. Proceed to adjust the brake pedal and the brake pedal position switch to correct any misalignment that may be affecting its function. After making adjustments, turn the vehicle back to the on mode without pressing the brake pedal. Recheck the signal parameters using the HDS to see if they now read close. If these conditions match, the failure may have been corrected through proper installation. However, if the parameters still do not align with the threshold values, further investigation will be necessary, prompting the technician to delve deeper into the electrical connections or potential failures within the circuit. In this step, turn the vehicle off to ensure safety during testing. Disconnect the 4P connector from the brake pedal position switch to isolate it from the system. Once disconnected, utilize a jumper wire to connect terminals A and B of the connector, a process that essentially mimics the switch being activated. After completing the jump, turn the vehicle back to the on mode and check the HDS for parameter readings. The focus here is to establish whether a close condition has returned in the cruise brake SWS/idle_stop switch parameters. If the readings still do not match expectations, further analysis is needed to determine whether there is a fault within the brake pedal position switch itself or elsewhere in the system, such as wiring or connectors. Check for issues with the IG1 ACG line by first turning the vehicle to off mode to prepare for the test safely. After disconnecting the jumper wire from the brake pedal position switch 4P connector, move on to measuring the voltage between designated test points. Specifically, connect your voltmeter between test point 1, brake pedal position switch 4P connector number 4, and point 2, body ground. Ensure the vehicle is on during this test. If battery voltage is present, this signifies that the IG1 ACG wire is functioning correctly. However, should there be an absence of voltage, it indicates a potential fault in the wiring, and further diagnosis of circuit integrity will be needed to resolve the issue effectively. For this troubleshooting step, begin with the vehicle in the off position to guarantee safety. Jump the SCS line using the HDS, ensuring to wait for more than 1 minute before proceeding. Disconnect the PCM connector A, 50P, to isolate the system for testing. Use jumper wires to connect terminals A and B from the brake pedal position switch 4P connector. Then, turn the vehicle to on mode again and measure the voltage at test point 1, PCM connector A number 49 against test point 2, body ground. An indication of battery voltage here means that the brake pedal position switch wiring is intact, and further investigation into potential PCM issues can proceed. If not, a thorough examination for an open circuit in the wiring between the PCM and the brake switch is necessary. Start this step by ensuring the vehicle is in the off position to set the stage for safe diagnosis. Locate and check fuse B21, which is a 10 amp fuse found in the under-dash fuse/relay box. This fuse is crucial as it protects the circuits related to the brake pedal position switch. If the fuse is intact, the next task will be to investigate the wiring integrity between the fuse and the brake switch for any open circuits. Conversely, if you find that the fuse is blown, it must be replaced, and the circuit should be tested for shorts to ground to prevent future failures. Addressing fuse-related issues is pivotal in ensuring proper electrical functionality within your Honda Civic. Upon reaching this troubleshooting stage, switch the vehicle to the on mode while pressing the brake pedal. Using the HDS, monitor the brake pedal position switch signal parameters. The expected reading for the cruise brake SW, idle stop SW, should indicate open while the pedal is engaged. If the parameters meet expectations, it suggests that the system is currently functioning correctly, albeit possibly experiencing intermittent failures. This is an important time to investigate any loose connections or corroded terminals that may affect the signal integrity. If DTC snapshots indicate faults, try to reproduce those conditions to observe if the error can be replicated, aiding further diagnosis and potentially confirming the ultimate cause. In this final troubleshooting step, test the functionality of the brake pedal position switch directly. If the switch operates correctly, it indicates no internal faults, but further investigation is needed for wiring leading to the PCM. If the switch is determined to be faulty during testing, it will need to be replaced. Ensuring the switch is fully operational is critical for the successful communication between the brake system and engine functions. Upon replacement, a final check should be conducted to ensure that all parameters are displaying correctly and that DTC P0703 does not resurface. This ensures the Honda Civic operates safely and all systems relying on brake status are correctly managed. After completing the troubleshooting steps for DTC P0703, it's essential to conduct a final verification of the repairs done. Start by ensuring that no additional diagnostic trouble codes, DTCs, appear in the system, indicating that any issues have been resolved. It's also critical to check the functionality of all systems that rely on the brake pedal position switch to ensure they are operating as expected. If required, perform a road test to assess real driving conditions. This final check confirms that the repair efforts have been effective and that the vehicle meets safety standards. Maintaining accurate records of the process is beneficial for future reference and can assist in ongoing vehicle maintenance. To prevent issues related to the brake pedal position switch, it's essential to practice regular preventive maintenance strategies. Schedule routine inspections of the brake pedal position switch and its wiring to monitor for wear, corrosion, or misalignment. Cleaning connectors and ensuring that all components are securely fastened will significantly benefit long-term reliability. It may also be wise to implement checks that involve the HDS to monitor signals preemptively, helping to catch any growing issues before they trigger DTCs. Keeping the vehicle maintained not only enhances safety, but can also lead to prolonged component life and diminished repair costs over time. Addressing DTC P0703 efficiently requires a comprehensive understanding of the brake pedal position switch's functions and relationships with critical vehicle systems. Identifying issues early through symptoms such as cruise control failure and engine idle problems can significantly enhance vehicle stability and safety. Following a systematic troubleshooting process allows mechanics to pinpoint the root of the problem effectively, whether it's the switch, wiring, or fuses. Regular maintenance practices can help mitigate future risks associated with the brake pedal position switch, ensuring reliable performance. In conclusion, understanding this DTC and implementing preventative measures contributes to safer driving and optimally functioning Honda Civics from 2016 to 2021. Please like and subscribe to the channel. See you next time.